NC State and Purdue. In addition, we have another partner, ISRIC, and I'll show that a little later. We work closely with industry, federal agencies, including several USDA groups. And our goal is twofold. So one is to actually advance AI, using knowledge from agriculture and forestry. And second, also to use that to help address some problems in agriculture, primarily climate smart agriculture and forestry, right? And we have educational mission as well. So it's a broad mission. So this AI climate is an acronym. And if you see the most important letter here is L, which is land. And I guess in your college, we all understand land often represents agriculture, forestry, even to some extent grassland and wetland. And then, our unique focus is on mitigation. NIFA has funded 5 AI institutes. All of them have some focus on adaptation, but I think we are closest to mitigation. Also, forestry is in our purview and others are less interested in that, right? So this is sort of the acronym, but primarily you can think of climate mitigation by spurring the adoption of climate smart practices. So let me go to the next slide. There it is. So before we go to the topic, I just wanted to set broad context. This probably most people in the agriculture space know it very well. But if there are people outside agriculture, I just wanted to share my understanding of the space, right? So agriculture is societally very important. Not only it provides the food, but also animal feeds, paper production, that's fiber, and biofuel. So there is a variety of things that we get from agriculture forestry sector. In US may represent about 10% of US jobs. So it's a major economic sector. But people who are outside agriculture, let's say my colleagues in computer science, it's also important for them to know that many technologies which are developed, agriculture tends to be early adopter. So within my own specialty, spatial computing, for example, differential GPS in late 90s were adopted first by agriculture, well before it came to smartphones or cars and so on. And in recent years, there are similar stories about UAV and so on. So agriculture is a sector which is not just interesting to rural economy, but also many urban and high-tech things, right? Coming closer to the climate, the farmers and foresters are also steward of natural resources, and they often have practices to conserve these resources for future generation. Right? And within that context, they do play a role in curbing climate change, right? We all know climate change is a big issue. On the right-hand side, we are actually showing the current strategy, broadly known as the net zero strategy to reduce or control climate change. And Paris Agreement and those really want to kind of go to net zero emissions by mid-century. But if you see the path to that, we have to reduce emissions, which is this top part, right? So electric vehicles or renewable energy and so on, they will reduce it. But it will take much longer than mid-century to actually reduce it to zero. And in some cases, it may be very hard. So also we need net negative technologies, what is called carbon removal. And there are at least 3 or 4 promising ones. But agriculture and forestry is one of the 4 big ones. So, and it's so soils, forest, nature, people have estimated, somewhere between 20 to 30% of the current emissions could be removed through the land and natural solutions, right? Furthermore, today, agriculture does contribute to the greenhouse gas emissions, about 10% nationally. But in agricultural states like Minnesota or other countries worldwide, the emissions are a little bit higher, right? So in terms of climate change mitigation, there are 2 different pathways. One is to reduce the emissions from agriculture and so on. And second is to actually go to net negative and absorb emissions from other sectors. Okay. So I'll go to the next slide and also mention that, despite all the societal promises, agriculture is facing number of changes. And climate change and environmental degradation is also one of the biggest changes. So for example, in the right picture, this is something many of the people in agriculture know very well. if we stay with current agricultural practices, then the yields are projected to actually decline, which is shown by this red line, because the climate change stresses the crops. And in addition, problems like infestation and so on are becoming harder because many species are moving towards the cooler climate, the away towards the pole or to higher elevation, and that stresses many things. So if we wanted to still, maintain our current food supply or actually grow it a little bit because the population and demand is growing, we need a set of climate smart practices, right? Now, there are other challenges, such as cyber or social challenges, ranging from aging workforce, and that's another place AI can play a role by automating some routine tasks. Um, and there are, challenges in terms of broadband and many other things. But in this talk, we'll primarily be thinking about promoting climate smart practices, both to reduce the risks from climate change and also to mitigate climate change. Okay. So to summarize, we can essentially say that, if you look at the current situation, the, the country wants to move towards net zero and the world. And one of the most promising way is to use natural systems. Its potential is almost a fifth, in some cases even higher, to absorb, to reduce emissions as well as absorb emissions from other sectors, right? And that is sort of our goal. But and also this is not a new idea. In fact, for decades people have been thinking about it, and there are many climate smart practices. Farmers are even aware of many of them, and some of the practices have been widely adopted. For example, if we think about no tilling, it's estimated that majority of farmers have already adopted that. Even John Deere tractors, if you look at the systems they sell, they're trying to move away from tilling. But then there are other practices such as cover crops or biochar and so on, where things are not as black and white. Cover crops do well in warmer states, even up to Indiana, but colder states like Minnesota, it's not clear if they are really helping. It depends on the climate and the weather and things of that kind, right? And so on. So before we started, writing this proposal, or during that, we had done a survey to actually ask farmers, foresters, and industry group to say what kind of research is really needed. And what we learned was that they knew many climate smart practices, but they wanted help in choosing between them. So basically the question they were asking is which climate smart practice should be used where, when, and how long, right? And in this context, AI, we felt was a possible solution. It can help by providing better data, models, algorithms, and tools. And I'm going to illustrate each one of those. And also my belief is that your college, you have held a AI for Agriculture conference recently. So many of you also have been working in this area. So I look forward to also learning from you via questions, comments, and advice, and also share a few things that our institute is trying, right? The left bottom is a picture from NIFA, which is showing many climate smart practices. And NRCS and other, they actually even provide subsidies. So again, the point is, people know many practices, so maybe we can invent new practices, but right now it's more important to figure out how to choose, and that's what our focus is. All right, so with this, we can kind of set the vision for this AI Institute. And this vision is twofold. And the first, as you notice, it says transform the science of AI. Because, despite all the success in recent years, right? Many of you have probably been, hearing about Chat GPT and GPT, and AI has been in the media, for the last couple of years. It seems to be very successful, but we all know that it's not perfect. There are problems like hallucinations. And if you actually dig deeper, these data-driven machine learning or statistical methods also have other challenges. Many of them are trained on benchmark data, which are not necessarily representative of all situations. And when you go out of sample, their predictions, their accuracy is, sometimes questionable. And in many areas, if you think about tech industry showing advertisement on the web pages, they can tolerate the errors because the costs are very small. But when you think about giving advice to farmers, the error and incorrect suggestion may mean that a whole season worth of crops and other things are lost. And so the cost is much higher in our space. And that's why we may not be able to just take existing AI and tolerate all the hallucinations. We need to understand the cost and improve the AI. And I will show you some of those things that we are thinking about, right? So that is one thing. And then, of course, use those AI to improve decision support in agriculture and forestry in order to help farmers and foresters choose, compare different climate smart practices and choose between them. Right? So we'll kind of go next and show, how we are kind of formulating the approach with the next slide. So before that, just to give you a sense of the participants in this institute, the first, I had already mentioned 5 universities. So Minnesota is kind of coordinating it, but Cornell, Colorado State, again, have very big roles. Purdue is helping on the education front. North Carolina State is on remote sensing. Delaware State is looking at some of the minority farmers. And then also ISRIC, some of you might know this soil reference information consortium in Europe, and they provide us a lot of soil data and guidance on that. So these are the core members, and then we have interactions with some of the industries in the space, as well as government agencies. And within our own team, there have been past projects which are listed on the left. Okay. This is showing you the team members, and this is grouped by the disciplines. So the left-hand side, you see AI members. Top middle, you see climate smart agriculture and forestry members. On the right-hand side, cyber infrastructure, applied economics, as well as the broader impact group. And I will, as I highlight the project, I'll highlight a few names as we go along. So in AI space, I'll probably highlight some work of Professor Vipin Kumar, Professor Carla Gomez, and in the agriculture side, same way, a few, and so on. Okay, so let's kind of look at our whole approach. And as I mentioned, we started by assessing the needs of the stakeholder. So there was a survey done during the proposal writing. And once the project has started, we have continued with focus groups. So we are actually in touch with several farming groups and even climate smart commodities group to understand what they really need. Which tools they prefer, what are the limitations of those tools, and other needs of this kind, right? So left-hand side are stakeholder needs. And based on that, we have tried to define our research problems, education, workforce, collaboration, nexus need, and organize it through the management and so on, right? But the overall vision is that, we want to create AI-powered climate smart practices and greenhouse gas market. So this is a very long-term idea. And part of that could be new, discipline. Part of that could be new community of practice, right? I mean, so those are the sort of more specific things. So trying to create AI discipline, this is one place we would actually love to collaborate with UFL, right? You were part of that AI for Agriculture conference. And as you try to create a community, I mean, those things are important, a place where people can meet. So for example, I believe PVAMU was also part of that conference, and they hosted it last year. So next year, we have been in conversation to see if we can participate and collaborate on that, right? And similarly, on the industry side, we have been discussing with climate smart commodities and other groups to see if we can similarly create some groups, workshops, panel discussions, and so on to build a community, right? And of course, we will also be doing some of the, research and things of that kind. And I will go down to a little more detail of our own work within AI climate in next few slides. Okay. So coming back to the survey, as I mentioned, there were 2 basic needs. One was from carbon markets side. And mostly they were saying that, today with the price, and subsidy for soil carbon sequestration, or even forest carbon sequestration, they have many open research questions. There are many, many questions, and you have probably seen that debate. Congress in IRA had put in quite a bit of money for NRCS to subsidize adoption of climate smart practices by farmers, foresters, and other group. But there are science questions like permanence of those soil carbon sequestration in soil or in the same way in forestry, because there are many uncertainties such as forest perturbation, infestation, fire, and things of that kind. So forest biomass estimation is a problem. A lot of people are interested in, not only in government, but a lot of private investment is also looking at that. And the similar things, if NRCS is subsidizing farmers to sequester carbon in soil, there are a lot of questions about the scientific, backing for those kind of practices. And of course, if you start talking to the farmers and forester, they want comparison. They said, okay, we are getting paid for different practices, but we want to understand which one is most suitable for our space, right? So that we can choose wisely. So here, for example, we are showing you a tool called collaborative geodesign. This is part of our preliminary work. And this tool, for example, helps multiple landowners in a watershed pick climate smart practices. So on the right-hand side, you are seeing a few climate smart practices here, such as conservation tillage with stover removal, or low phosphorus, or prairie grass or switchgrass. So prairie grass is to protect the water bodies that you see in blue here, and so on. And this tool basically has two modes. In the interactive mode, each landowner can choose these practices for their own farms or plots, right? And once they do that, then this tool runs economic models as well as environmental models in the background, and comes back and tells the farmer the economic cost of benefit as well as environmental cost of benefit of their decisions. Furthermore, the landowners are able to see interactions of their decision and to other landowners' plots. So, for example, upstream and downstream, you might have soil runoff and so on. So all those models are run. And then there is social learning. The landowners can see the overall picture, and they can go back and refine their decisions if they see something undesirable, and ultimately settle on something. And this picture is showing you one particular example in a large watershed, about few 100,000 acres, and how ultimately this farmers settled on different decisions. And this is one example where these kind of simulation tools can help landowners kind of choose these decisions, whether you do it in isolation, each landowner does it on their own, or you do it in a watershed in a more coordinated manner. And we have other tools of this kind at even higher level, policy level. Okay. So I'll continue. So we kind of got the need assessment. It's mostly on decision support. And once we went past that, then we started analyzing the actual problems in agriculture and forestry. So this is a very busy slide. I will break it into three parts. So let's look at the left-hand side, which says integrative vignettes. So these are essentially using agriculture, forestry kind of language. And these are the specific problems in agriculture and forestry which are being explored by the team currently. So for example, the first one you just saw, I had been talking about accuracy of a current estimation model for soil organic carbon or soil emissions and things of that kind, right? Or forest, biomass. And that's a big area of need. We heard from many, and there are several team members who are focused on that, right? And other ones. So if you start looking at interaction between agriculture and forestry, we all know that in many areas of the world, the forest is getting converted to cropland, right? We have heard, seen that in Brazil or in Indonesia. And that actually leads to more emissions, usually. So some of the group members are actually looking at those interactions and so on, right? And there are some economic models. These are at country level. If the countries are interested in estimating their environmental, sort of like GDP, there is similarly environmental benefits some countries have been tracking, like China, and we have people who do that kind of a modeling. So essentially from agriculture, forestry side, there are roughly 5 topics that were picked. And within context of those topics, then we had discussions to say whether the current AI tools and techniques are adequate. And what the group felt was they were not, and there were a bunch of knowledge gaps in context of AI. The first one I had talked about earlier. The current machine learning and statistical techniques are usually trained on a benchmark. And oftentimes that benchmark construction is not, I would say, as rigorous as it could be. For example, if many of you know computer vision and ImageNet, which has had a lot of publicity, and then pretty soon people realized that it was highly biased, right? People with dark skin, female dark skin, the accuracy was much low because it was not represented in that data very well, right? And so on. And there are similar issues with almost all benchmarks used in machine learning and AI. There has been debate. There is a AAA science article, if you want, I can share. And it basically, I think the title is Educated to Test. And it basically says, yeah, on the benchmark, they do well. But once they go out, away from benchmark in new situations, they can embarrass you. So you have to be careful. And purely data-driven methods, it's very hard to do that. So one of the topics that we are exploring within AI is what we call knowledge-guided machine learning, which is a broader, framework than physics-informed neural network. But here the idea is to leverage scientific knowledge, because oftentimes scientific models are designed to be a little bit more general, not just to work on a given data set. So if we combine the strength of data and science, we hope that these methods may have better performance on that data we haven't seen so far, and so on. And there are other similar challenges, and for those there are AI research that is kind of proposed, and I will illustrate a couple of them as we go forward in a broader language. So let me actually pause and see if there are any questions. So Dr. Lee, do you see any questions in chat and so on?
So far, we don't have any questions.
Okay.
Yeah.
Great. Good. So let me then get into a little more specifics. This is the broad framing. And from agriculture, or I would say we have to be, worried, thinking about farmers, foresters, and adoption, because that's one thing our, NIFA colleagues really are very interested in adoption. So yes, AI, I can talk about all the fancy language, but at the end of the day, we have to translate to what the end users will appreciate. So we are saying, okay, all that AI can help you with, create better data, better tools, models, and algorithms. And I'm going to next kind of illustrate each one of them, at least based on the results we have so far. And hopefully, down the road, we can come back and show you more. So let's kind of look at the next one, which is an example of better data. And soil organic carbon also, we have been working on that. But right now in the results so far in first year and a half, we can share something about soil moisture mapping. And at the bottom, you see this paper, ACM6 Spatial. It's going to be presented actually in 2 weeks, end of this month, but it has been accepted. This is by our Colorado State colleagues, Professor Shrideep Palikara and the student Pahuni Khandelwal, and so on. So as you know, if you look at soil moisture map, maybe in Florida, you probably don't have to worry about dryness as much. But states like, Colorado or even, Minnesota nowadays, some weeks, months are very dry. Like this month is very dry. Some months we have plenty of water. But soil moisture, as you know, is a key input. And even in adoption of climate smart practices is very important. Cover crops, if you are very dry weather, cover crops can actually hurt the future crops by reducing the moisture, right? But if it is wet, then it can actually help by removing some of the moisture and make things a little more helpful to your crops. So one of the projects is on mapping soil moisture. If we look at the current state of the art, which is shown in the left figure, we can get satellite measurements, but it has very coarse resolution, few kilometers. New satellites are on the horizon, right? If we get the NISAR, next year or year after, it will improve the resolution. But right now, it is very, very sparse. So some states like Oklahoma that you can recognize here in the map, you see Oklahoma has pretty rich sensor network, and few other states also have good sensor networks. So if you can combine these sensor networks with satellite data and use machine learning to interpolate and extrapolate. So you basically train your machine learning model on the areas which have a lot of sensors and satellite imagery, and then take that model and try to predict in areas which have fewer sensors, then you can improve the data quality. So here on the right, you are seeing a result from our group, Professor Shri Palikara, which is showing you a much higher resolution soil moisture map. I hope on your screens you can see the difference between two maps. Are you able to see the right map has higher resolution than the left map?
Yes, we can see.
Wonderful. So this is a big, direction. And also our colleague in ISRIC, who traditionally were mapping soil carbon, they are getting very interested in actually mapping soil moisture. And as you know, climate change is also increasing the variability of precipitation. So this problem is likely to become even more interesting and important as time goes by. For example, Minnesota, previous, it used to be considered water rich most of the time. But recent, decades, it's water rich in some month and water poor in some month. So anyway, this is one of the example of better data. And we hope to develop similar models for soil carbon mapping. In fact, there is one paper out from the Cornell group for global carbon soil mapping where they have used AI methods, and they actually showed better performance than the purely satellite data as well as the physical models. But I'm going to show you soil carbon example for a different context. Okay. All right. So we can improve data of different kind. Let's also look at the tools, and we are actually, working with several different tools. I had already described AI geodesign, which is at watershed scale, and it allows social learning amongst landowners. But another tool, which is at a single landowner level, is called Comet Farm. May I actually have a quick show of hand? How many of us are familiar with Comet Farm or Comet Planner? It's promoted by USDA, and our Colorado State colleagues are very heavily involved in developing it. And maybe Dr. Lee, if you can just tell me if you see any hands up about Comet Farm.
Sure. Yeah, for all the participants, you can raise your hand for your reaction using the reaction. Oh, at least I saw one participant typed in the chat box.
Okay.
Yeah, very
Good.
familiar with the Comet. Yeah.
Wonderful. So Comet Farm is a more sophisticated tool, but single landowner, and its simplified version is called Comet Planner. And Comet Planner is actually written into legislation. So if you look at IRA, when they are giving funding to climate smart commodities group, they are encouraged to use Comet Planner. So this is a great, you can set, pathway for us to make impact. So if our AI ideas can make into these tools like Comet Planner, then that gives us a pathway to go to the farmers who are using it and climate smart commodity group. So this is another tool, but it's at a single landowner level. And it's very detailed. It can compare many, many climate smart practices and provide the estimates. However, you see, we are actually proposing AI Comet Farm. So Comet Farm, has been used by farmers for a while, but farmers also have some complaints, so to say, and they say the predictions are not very accurate, right? And this is actually the basis of the whole proposal. In fact, when this RFP came out, our Colorado State colleagues, they contacted Minnesota colleagues, and I will show you why. Because some of our colleagues were using machine learning to improve the prediction of soil emissions and so on, right? So essentially, in Comet Farm, we want to go from Comet Farm to AI Comet Farm by using AI and machine learning to improve prediction accuracy, right? There is another tool called Soils Revealed, and this is from our Cornell colleague and ISRIC. And this is at policymaker and country level where you can, look at the soil different attributes like soil carbon and things of that kind. But we have a bunch of tools, and that sort of is our pathway to impact and adoption and technology transition. And various data sets, algorithms, and models will go into these tools. So we'll go to the next one. Again, now kind of tell you why this proposal or this team came together. And this is a paper, as you see, the paper actually came out this year in Nature Communication. But you can imagine that preliminary work was already happening and people knew about it. And let me first actually show you what is in this figure. So this figure is about predicting one of the soil emissions, N2O. And probably, again, if you probably know that, when you put fertilizer, nitrate, and if there is a lot of moisture, the bacteria will break down that nitrate to take oxygen out and emit this greenhouse gas N2O. Okay. So in areas like Minnesota, sometimes the nitrate fertilizer is applied actually in fall before snowfall, because after the snow melts, the window to actually go in the farm and do the work has become very narrow. It's getting narrower and narrower with the climate change. So anyway, this N2O emission is one of the soil emissions of concern. So people want to predict it, and there are different models. So the classical model is shown in the green line. You see process-based models such as EcoSys is one, and there are many other models. But this is largely physics-based with very small amount of empirical component. And these little dots are actual observation. We have observations in greenhouse and field. And you kind of see this green line, fits some of the observation well, but it misses quite a few. Okay. Now, other people have tried purely data-driven approach. The GRU, the blue line is purely data-driven AI neural network. And again, you see it fits some data well, but it misses some data. And some of our colleagues, Professor Vipin Kumar, Zinong Jin, and others, they have used a combination of the two, knowledge-guided machine learning, which uses not only the data, but also the scientific knowledge and machine learning together. And you notice the red line fits the data better. Okay. So this is the reason the Colorado State colleagues kind of, came to Minnesota colleagues and say, we ought to work together. And there were similar synergies with other groups as well, right? So this is a very promising part. In fact, during the proposal, we hypothesized that this could improve Comet Farm, and then that could help farmers. And during even the first year and annual review, we kept saying this. But actually, USDA has bought that argument. And in July, they invited us to their headquarters. We met with a whole bunch of agencies, the NRCS and so on. And they basically said, okay, we seemed this is a promising path, but we want you to try Comet Planner because that's what farmers can use right away. So this is a path we are now developing next steps and trying to see if that impact pathway comes, through in this project. That will really be a nice story end to end, not just papers, but from these outputs, we can go to outcomes and impact, right? But nonetheless, you can kind of see prediction models, and this should not surprise any of us, right? Machine learning is all about prediction. So hopefully, if all the AI, successes in other fields, the Nobel Prize in chemistry and physics, probably, we should think, yeah, AI should be able to do something in prediction range. We just need to pin down when and where and how effectively, right? So I'll continue to some other components and pretty soon. But basically here, this idea is using KGML, we improve the models of soil emissions or soil carbon and things of that kind, right? But here it's not just helping the agriculture, it's also actually advancing AI. So for example, when you see this notion of KGML and PIN, it is showing you how these physical constraints are being added to neural network architecture. And once we do that, you can actually model these physical, scientific constraints and reduce spurious prediction. Remember, we were talking about hallucination. Since the pure data-driven methods do not know these scientific constraints like conservation of mass, their predictions have the risk of violating them, and that can make the predictions less acceptable to agriculture and forestry community. But by bringing these things in the neural network, we are likely to reduce this. And also it turns out that you improve the prediction, right? So this is a big area. In fact, KGML is an area where our group is also trying to build national community. Professor Vipin Kumar just hosted a KGML workshop in August with many participants. And he was also co-organizing AI for Science workshop for NSF, March 2023. And the second one happened in July on our campus, where these kinds of ideas are being shown to not just agriculture, forestry, but wide variety of scientific communities, because this may help many, many places. So this is one way we are actually advancing AI for many scientific community, but with the specific case studies and use cases in agriculture. Let's go to the last one, which may look a little bit removed from the discussion so far, but I will try to connect this as well, okay? And the best way to connect it is to think about, let's say, the geodesign tool that I was showing, where the farmers were trying to, choose between climate smart practices, right? And when they were, making those choices, they had two very different kind of dimension. One was, environmental or ecological variable. Here it's shown on the Y, in case of Amazon basis. But the other is economic. So that's shown on X. So there is basically, economic and environmental, at least two different criteria. But if you are in the field, you can probably understand that, the environmental itself has many factors because there are different types of emissions and environmental impact. And same way economic may have that. But at the end of the day, what we are saying is it's a multi-objective optimization. And it's nice if we can get the Pareto frontier, that will be very good. Now, in geodesign tool, when farmers select those decisions by manually and socially, it turns out that they stay in a very small corner. They stay in a small corner where the environmental benefits are very small and the economic impact is also very small. Okay? So geodesign tool in the back, we also run an optimizer to make recommendations so that we can give them suggestions on various points on this Pareto frontier, right? And in order to make those recommendations, we need a very fast optimization algorithm for multi-objective optimization problem. So that sort of is the connection. And it turns out that, as you start increasing the dimensions and size of the problem, the current multi-objective optimization algorithms start to stall. I mean, as you know, even linear programming after 100,000 variable runs into trouble computationally. And then large farms, when you're starting with plots and so on. So we need to scale it up. And that's what this is about. Our colleague, Professor Carla Gomez, is a leader in this space, and she's going to work with GeoDesign as well as other tools to speed up this multi-objective optimization algorithm using AI for pruning. So AI can be used to speed up these algorithms. And I will just watch the time. Looks like, okay. But you have now gotten the gist of the, the work. And now we can go and give you some of the small things. So basically, these scalable algorithms can be used with our collaborative geodesign tool to make recommendations. And this picture is also showing you farmers interacting with the tool. And then all the background models, they are showing you environmental and economic benefits for each farmer, and they can iterate. And they can also look at recommendations from these optimization algorithm. And this is the picture I was showing you if farmers, when they do manual design, their choices are sort of in one corner where the environmental benefit is relatively small and economic impact is small. But with these kind of tools, we can give them recommendations all along the Pareto frontier and see if they are interested in adopting some of them. And over there also, remember, we can, the government subsidizes some of these. So even the small economic loss may get covered by the subsidy, or the subsidies may be designed accordingly. Yeah. All right. So those were kind of the more technical theme. Moving beyond the research, we can also see there are other themes in this project, one of which is collaboration and knowledge transfer. So we have a mandate to bring like-minded people together who are interested in spurring the adoption of climate smart practices to mitigate climate change. And here we are showing you different groups. And we have started to engage them one by one. With panel discussions, hopefully in year 2 and 3, through conference and workshops. And I hope if AI for Agriculture, we can collaborate. I hope we can create activities to bring some of these groups together for, brainstorming and figuring out what are the new things that can be done. Okay. So there's some groups we are already working. So for example, some of us know FFAR, that's an industry group. The user community of these tools, we interact with those. And so on. There is also Climate Smart Commodities Group, which came, they were funded just around when our center was funded. So that's a big change since the proposal, and we have been interacting with them to see what we can do together with them, right? And overall approach, all of us know this is probably not a surprise in agriculture. Agriculture has a very rich tradition of working with the customers, right? To select questions, make discoveries and evaluation. So this slide is more aimed at our AI colleagues, computer science and AI, we are a little bit new to this game. And but in this particular project, whether the person is from AI or agriculture, we are all following this particular strategy. Okay. And this I will skip, but basically, we take system of system approach. We are trying to take problems which have, which are important, but have not been solved using traditional physics-based approach and using AI to see if we can make a dent. And we are working together with our user community. So the hope is that, if we are sort of away from Pareto optimal, first we will try to reach Pareto optimal, but also by designing new techniques, maybe we can shift the Pareto optimal forward. And that's sort of a vision thing, right? So with this, I'll kind of just show you a few activities that happened in year 1. So, we are very fortunate to be part of AI, Institute program. It's a very nice platform that gives us great opportunities. So you kind of see, they organized an event in US Senate called Hill AI Institute Day. That was about a year ago. And every AI institute was there to make presentation. And we were there, we met several different government agencies. We have had visits by NSF and USDA leadership that you are seeing over here. And then, even AI Leadership Summit, you kind of see some people here you might recognize. This is, I think, Dr. Steve Thompson. From NIFA side, he is program manager, and you're seeing Dr. Jim Donlan from NSF side. He leads the AI Institute program. We have had, retreats, annual review, and here you see a picture from May 2024 when large part of the team came together. We had similar meetings a year ago, and every year, we are doing things of that kind. Okay. We have also had a lot of outreach, within US and abroad, talking to policymakers and things of that kind. And we look forward to having more of this with like-minded collaborators. This is showing a few facilities we have. So for greenhouse gas emission measurement, we have some greenhouse facility. Professor Tim Griffiths runs that with the US, with NSF and NIFA support. We have a ARS on campus, which actually has these flux chambers on the field to measure emissions like N2O that I was talking about. And you are seeing these N2O being plotted from this measurement, Rod Venturia's lab. In addition, we also have other groups like Forever Green, which is looking at many of these climate smart crops. Camelina, as you know, can be used to create aviation biofuel, and Delta Airlines just made one of the first flight from US to Europe using this biofuel. And of course, Johannes is a leader on biochar. So we have a lot of other strengths, and as time goes by, we look forward to having more activities and insights from there. So with this, I think we are reaching the end of the talk. So I'll probably leave a bunch of time for the questions. But broad messages, agriculture and forestry are societally very important, not just for rural economy, but also for urban. They are facing challenges from, particularly from climate change. So it's important to adopt climate smart practices. Also, they are a solution to climate change. They can absorb greenhouse gases. And many land stewards are aware of those. They have been aware of the subsidies. Some of the practices have been adopted. So through our survey and focus group, we learned the central question they want to ask is, how do we compare these practices? How do we choose between them in terms of location, seasons, and duration, and things of that kind? And in order to do that, they need better data, such as better data about soil moisture or soil organic carbon, etc. They need better decision support. For example, Comet Planner or Comet Farm, their prediction accuracy needs to be improved. In geodesign, we need to have a little better set of recommendations, quicker and faster for larger scale scenarios. We need to have better prediction model, for example, for soil emissions or forest biomass. And we want to have faster algorithms and so on. So I think this is a good place to stop. Let me stop here and take questions. So I'll stop sharing if needed, if I might come back and share and show some other things.
Okay, yeah, thank you very much, Dr. Shekhar, for your excellent presentation to introduce your AI Institute. So now we have a couple of questions from the audience in the chat box. Can you see those questions?
Sure. So I see the first one with Miami Joe. The model of farmers using tool to understand tillage, etc. But a bigger problem is conservation of farms, such as declining orange farms into housing development has a more profound effect on watershed. Okay, so I fully agree. I fully agree. And if you remember the second vignette in our agriculture, climate smart agriculture, forestry was of a similar nature, where we were saying that, worldwide, some of the agricultural land, just like you mentioned, orange farms, but same way rainforest in Brazil is being converted to produce, I believe, soybean and beef. And Indonesia, some of that is being converted for palm oil. And even in United States, there may be pressure because we all know with climate change, the plants, right, all species are trying to move to slightly, towards the pole or to higher elevation, right? In fact, if you look at the footprint of corn, right? The warmer areas with climate change may become inhospitable for corn. In fact, Minnesota used to be much bigger corn producer 30 years ago, and it's not as big a player anymore. It's kind of has moved north and so on. So yes, it is a very important problem, and that is a theme. Nathan Mueller from Colorado State and some of the other colleagues are looking at that trade-off. And there are multiple ways to think about it. How, what can we really do about it, right? So first level at which, we are thinking about is at policy level. So we have a group on Earth economy model. So you might have heard of Stephen Pulaski, but his mentee Justin Johnson is part of the group. And what they do is to kind of run all these global, scenarios. And you say, okay, if we know that it's possible for people to convert, right? And there will be pressures for that, whether they are economic pressures or climate pressures. But you can run a scenario and say, well, if you let that happen, this is what will be your economic impact, and this is what will be your environmental impact. But you can also run alternative scenarios saying if the government somehow intervenes, puts subsidy or some other incentive to discourage that kind of um, a thing, then what will be the impact on economic environmental thing? So at least we can make policymakers and other people aware of the trade-offs. Now, what are the solutions? Can you really go further? And that part actually is a little bit outside our scope, but you are seeing some ideas come up worldwide. I don't know how many of you saw that idea of carbon banks. So this has been proposed by, they're asking for over 100, I think, $1 billion to essentially pay people to store and preserve carbon and not convert it. So countries which are not, which are going to protect their forest and not convert it to agricultural land may get paid certain amount of money, right, for per unit carbon they are preserving. And so there are those ideas afloat, and there is at least one theme where we are looking at policy level comparison of those. So hopefully that kind of addresses it, although it was not specific to orange farms, right? Okay, so let me see. There is another question from Miami, which says, can your tool be adapted to broader set of competing problems? Okay, so I'm guessing it's probably just phrasing the first question well.
Yeah, I think they are related. Yeah, you already addressed that.
So our Earth economy model is probably closest to that. And, we NatCap project, is doing that. Okay, let's see. Then it says very familiar with Comet Farm. Thank you. Then Richard Dutt asks, while SMAP mission uses L-band microwave radiometry for soil moisture estimation, I was wondering if hyperspectral imagery in the near NIR or SWI ranges could be used to provide complementary information for improving the accuracy of soil moisture estimates. It's a very good question. And I think if you look at the NISAR satellite, which is jointly launched, is planned by US and India, and that's supposed to have, I think, exactly your idea. It's supposed to have better sensors and give you finer resolution for soil moisture. So I think they might also have some microwave kind of things because they are also going to be effective on polar region. But let me actually ask, are there some remote sensing people in the room who are familiar with NISAR and check whether they are just using NIR, S2WIR or other bands to improve resolution of soil moisture? Right?
Yeah, I think we should have some participants from the remote sensing area. Not sure whether they are familiar with all these different satellites sensors.
I can find Wikipedia link. It will go up, I believe, next year, the NISAR satellite. Wikipedia article only talks about polar region, but the people in IIT Bombay and Caltech had a workshop on soil moisture. So there are people involved in that who believe that it has soil moisture resolution potential.
Okay. That's great.
Yeah, I can at least the NASA link and you can look it up. Okay. Yeah. Cool.
So Dr. Shekhar, I have one question. Well, I think Miami just sent out some links for NASA's multispectral sensing. Okay. Anyway, my question is for your AI Institute project, it's quite impressive. You have a very ambitious goals. You engaged a lot of investigators, stakeholders. But for climate smart agriculture practices, I believe, at the UF, we also have faculty members, researchers are doing climate smart or soil sensing, soil moisture sensing, all this type of work. I believe other parts of the nation, different universities, they also investigate using AI sensors data to improve prediction. So I wonder for your AI Institute, how can you be more inclusive to kind of integrate the community efforts instead of creating competitions or duplications? Yeah, can you answer that question?
No, I look forward to suggestions on that. So first thing that we are thinking is that if the community can get together, then it's easier to interchange ideas, right? And so we have been looking at different pathways. So we saw that AI for Agriculture conference, I believe right? UF had hosted that year or 2 years.
Yeah, we hosted it last year.
Last year, and then PBA.
Yeah, this past year, Texas A&M hosted this year.
This year, and they are planning the next year. So that may be one place we get together and exchange ideas, right? There is also another option, but I don't know how many agriculture people want to go there. So AAAI, which is the AI Association, has a fall symposium series, and they have a workshop the first week of November on AI for agriculture, focusing on cybersecurity and this and that. So we are also trying to get there to have panel discussions and try to bring together people. I think Virginia Tech agriculture people are involved in that workshop, right? So, but right now the community is fragmented, if I may say, right? And we need to slowly kind of start bringing them together. And let's try the ones, the AI for Agriculture conference you are involved in. So next year, I believe PVMU, we have been talking to, they are very willing to bring us in. And if you support that, and then, we could have panel discussions on focus topics like soil moisture or soil organic one, right? And that will help us interchange ideas and things of that kind,
Okay.
Yeah.
All
but
right.
If you have other ideas, I will look forward to the guidance.
Okay.
Yeah.
Great. Thanks.
All right. There is another question on small drones. Okay.
Let's just comment, I think.
Comment. Okay. Sure. Yeah, small drones are great, but as you know, the agriculture, forestry, the areas are very vast. But maybe they can tell us which bands work best, and we can check. I believe Nisar is probably using some of those. Yeah.
I think Dr. Zhe Jiang is raising his hand. Please go ahead to ask your question.
Yeah. Hi, Professor Shekhar. Thanks for sharing the information. It's really exciting talk. And I just want to ask your thoughts or advice about how to, as a researcher, what is the best approach to make the research results in academia translated into practical impact, especially in climate domain. There's a lot of potential actions that could happen and make a difference.
Sure. So Zay, I asked Professor Lee whether you are part of the group, and he said you are on the mailing list. But let me take this opportunity to make sure two of you meet in person and chat.
Yes.
And Zay's question is very characteristic of the dilemma computer scientists have, because in past, for a variety of reasons, they haven't been as directly involved with the end user, right? But what it takes, Zay, is working closely with, domain scientists like Professor Lee. Because in agriculture domain, they are very involved with stakeholder. In fact, if they write a proposal to NIFA without having talked to their stakeholder, it may not go very far. Is that right, Professor Lee?
Yeah, of course. Yeah. That's right.
So we are learning, so same thing with Professor David Mula, we have been talking and he's from the agriculture side and we learned. So I would say your greatest resource is work with agriculture folks. Same way, many domains they do that. And in computer science, we need to build that. So I'm really appreciative you at least have interest, but time to meet face to face, walk in their shoes, right? And then pick up some best practices. Yeah.
That's great. So Dr. Shekhar, I have one more question. So to succeed in this AI Research Institute is, I think, very, very challenging. I mean, the competition is very fierce. So what did it take for you to really organize the team to succeed? Can you give us some advice for us?
Sure. So I think this was our third attempt. It was not easy for us either. So I should say that, right? But over the 3 times, I would say the part that probably helped us is, the last question was going there, a close collaboration between the AI computer science and agriculture. Okay. So if you actually read the solicitation, it asked for a virtuous cycle between foundational AI and use-inspired AI, right? And it actually distinguished those two terms from applied AI. And these three terms are very hard to interpret unless you work very closely together. Okay? So foundational AI is basically saying that people in AI community should also see it's advancing AI, right? That I was talking about the KGML and stuff, right? And use-inspired AI means you're doing something which advances both sides, both agriculture and AI, right? And that's very hard to do without talking several times and trying different ideas, right? So we were fortunate that, some of that was happening on campus for a few years. And then, we were also fortunate that this Comet farm, needed prediction accuracy improvement, and we had some preliminary. So there were a few accidents that happened. But I would say the biggest factor may have been that our AI and agriculture people had been talking for a very long time. My own conversation started with David Mula in 2015 by an accident. There was a deconstructing precision agriculture congressional reception in March 2015 to reach out to the members, congressional members from rural communities to show what science is doing, right? So Raj Khosla, Colorado State, who was, right, he was the organizer, and they chose to showcase three things: GPS, GIS, and sensor, right? And then, computer science leadership group, I had done some work with GIS. So they said, well, you are going there to talk about GIS for agriculture. And I said, oops, I haven't, don't have much exposure. So I went to David saying, David, please help me learn something. So it started there. Then we did a workshop together. This was an NSF infused data science workshop. We did that 2015 or 16 at NIFA headquarters. And so that also, it took some time. So we have, at least I tried to walk and learn, and he has been trying. But even during the proposal, these debates were happening. He will pull out a paper and saying, look, our colleagues, published this great AI paper at how it helps agriculture. And then we will parse and say, but that looks like applied AI. It does not look like use-inspired or foundational, right? So there was a lot of back and forth like that, right? Or vice versa. Our AI colleague will say, here is a great idea, federated learning. But it's foundational AI, but is it really, have you shown the benefit to agriculture yet, right? So, but all those conversations are very hard to do in 90 days once the RFP is out.
Yeah.
So key thing is to get started. And, now you do have some willing partners, Zay is here. And just do something together, maybe do a paper together or something, and that's to build the foundation. So we lucked out, it was something we were working on for a few years for a variety of reasons. Just time out.
Okay. Yeah, this is excellent suggestion. Thank you so much. I think we are running out of time. So yeah, I want to express my gratitude for Dr. Shekhar for spending his valuable time to give us an excellent presentation. We really enjoyed it. At the peak time, we had 38 participants. And we also recorded this seminar. If you're okay, can we post it on our AI seminar series webpage to benefit more people?
Sure.
Yeah. We hope we can continue to engage with you, Dr. Shekhar, get your advice, as we try also to compete for some large grants. For UF. Yeah.
Wonderful. Okay. Wonderful. And look forward to collaboration on AI for Agriculture conference and other things. Yeah. And if you don't mind, just send me a link to the video so that I can just watch, make sure.
Sure. We will do that before we post it. Okay. Thank you so much, Dr. Shekhar.
Thank you, everyone.
Have a great day. Thanks, everybody, for your participation. Take care. Bye-bye.
Bye.